Hello, everyone, and welcome. My name is Jonathan Hill. I'm an engineer here at ATA Engineering's East Coast office in Virginia, in the Washington, D.C. area. And today we're going to be taking a look at some of the really exciting new features that are available to us now with Femap 12. So before we jump into that too much, I have just a few housekeeping notes to point out. So first, everyone has been muted for now. But we'll have a question and answer session at the end of the webinar. So at that time, you'll be able to unmute yourself. You can unmute yourself to ask questions. You can also ask questions at any point using the chat, and I'll try to look at all those at the end if I don't see them during the presentation itself. A final note is that we're going to be recording today's demonstration and webinar, and we should have that available in the free resources section of our site in the next couple of days. So just keep that in mind if you want to review anything or share this with colleagues. I also would like to give a brief intro to ATA before we get into the exciting features in Femap 12. So to start with that, most of us are probably familiar with ATA either as a provider of high-value engineering services or through our role as a Siemens partner and reseller. And really, these two go hand in hand. So we have experience providing engineering services across a wide range of industries. This just starts to hint at all the different industries that we're involved with. And because we're solving the same issues as our software customers every day, it really helps us provide great software support. So on the services side of things, we tend to focus on analysis and test-driven design. And really, these are complete integrated solutions. So most of our engineers, myself included, are involved with at least two or normally all three of these items on the screen right now: design, analysis, and test. We're really proud to help our customers meet their toughest engineering challenges, whether that's through ground vibration tests on state-of-the-art aircraft or analyzing the next generation of planetary rovers. And of course, like I said, being experts with Siemens PLM software helps us to accomplish that. On the software side of things, we are a value-added reseller for Siemens PLM software, and I have a list on the screen right now showing the Siemens product lines that we support and can help you with. So that includes Femap and NX Nastran. We've recently added Star CCM Plus to our product line, and there's a variety of other products as well. So for each of these, we have a technical support hotline. You can call in or send a message through our website. And these are handled by our own engineers. So these are people that are using the software every day. And in addition to that technical support hotline, we have a variety of other resources for you, including help with licensing and sales and training classes. We offer training classes that range from introductions to FEA or introductions to Femap, all the way to more advanced topics such as dynamic response or super elements. We also have a software website, and there's a variety of content here that I'd invite you to check out. In addition to having a contact form for our hotline and a list of upcoming classes, it also has the latest software product information, such as this Femap 12 brochure. But probably the coolest part for me are all of the free resources that are available. So if you follow this yellow link up in the top right-hand corner of the webpage, we have a variety of free resources that covers white papers, tutorials, Femap APIs. It's all free, and it's all developed by our own engineers. So you won't find this content anywhere else. And I would also invite you to reach out to us if you have a topic that you would like us to pay more attention to, or an API that you think we could write for you. Reach out to us, and we'll let you know if we can incorporate that into our website. So having said all that, we're going to move on now to our feature presentation for today. Again, my name is Jonathan Hill. I'm an engineer here in our Virginia office. And at least personally, I'm really excited to have Femap 12 here. So let's take a look at what we'll be talking about today. We'll start off just with an introduction to Femap 12 and kind of talk and discuss about where Femap is headed. And then we'll dive into some demonstrations. So we'll talk about visualization and user interface enhancements. We'll cover some of the new things for geometry, as well as pre-processing, post-processing, and solver support. And for each of these, the way we're going to do it is I'll present a couple new items that are being added, and then I'll hop over to Femap to actually just demonstrate some things live, because I think that's even more powerful than just reading on a slide what the new features are. And then again, at the end, we'll have a question and answer session, so you'll be able to unmute yourself at that point and ask some questions. So first and foremost, Femap 12 is available now. You can download it today from the GTAC website if you have your web key. And an additional note, we've had some users who have trouble with their licensing with Femap 12. In some cases, it seems like Siemens has just either forgotten to send an updated license, or it got lost through the email service or something. So if you're having license trouble while you try to switch to Femap 12, let us know and we can help you get squared away with the correct license and everything. I also have some notes here on Femap's direction, but at the end of the day, Femap's direction is to continue like they have been. Femap has been really good about having a pretty major release every year or so, and that's gone back the last couple years, and we expect that to continue. And really the goal of all this is to maximize the efficiency of FEA tasks. So by this, I mean that we're going to continue trying to make the creation of high fidelity models more efficient so that we can accurately represent our real world problems. And we also want to be able to intuitively interpret those results so that we can actually use our analysis in the design of our engineered products. In addition, we'll accomplish all that just by continuing to build upon the capabilities that Femap is already really strong at. So that includes geometry idealization and processing. We'll have more powerful meshing enhancements, including some more interactive editing, and we'll take a closer look at that today as well. We'll see increased support for industry standard solvers, including NX and Astran, but others as well, such as Abacus and ANSYS. And finally, flexible customization tools. So we like to say that Femap out of the box can do about 99% of what any of us would ever need it to do. But for that last 1%, they provide us customization tools through the API and other things that make it easy for us to make Femap everything we need it to be. So let's start now with visualization and the user interface. Right off the bat, we're going to notice that the colors have been enhanced. There are new color schemes. The UI has sort of been pulled together and simplified so that it matches other Windows programming a little bit better. The buttons and the layout and everything is still going to be the same, but I hope that you'll agree, at least in my opinion, this new default background, sort of a light blue into a light gray, is easier to see than the original black to dark blue. So we'll take a look at that and how that can help us visualize our large models a little bit better. They've also introduced best possible graphics. So previously you could go in and you could manually control your graphics settings, and that option is still available to you, but what they've introduced with Femap 12 is best possible graphics. So I'll show you where this is. It's in File Preferences. And essentially what it does is Femap will query your computer. It will try to figure out what graphics hardware you have installed. And then based on that, it will make recommendations. And most of the time, this is going to be the best graphics options for us. One thing that I really love in Femap 12 is the live and interactive screen entities. So I'll show this off in a minute as well. But basically, any kind of information on the screen is now interactive. So by that, I mean the view legend, view axes, post titles. So what you can do, and we'll see this in a minute as well, but you can come over to your contour legend, for example, and you can start adding contour levels. You can click it and drag it around the screen. So there's some pretty powerful new functionality there. And then finally, I'll discuss silhouette and feature lines. So I have those shown here. That's what these red outlines are. That's mesh-based, and it has a break angle that you can specify. So let's hop over into Femap now, and we'll see how some of this starts to work. So this is Femap 12 now. Right off the bat, we'll see that the colors have been revamped a little bit. I do think that it makes it a little easier to view models on large monitors, or if you're presenting a demonstration or presenting results or anything. There's also some easier ways to control the background and things really quickly. So they've added a new custom tool, and I can come up to custom tools, views, view themes. And when I click on that, I get this new little toolbar on the side. I can easily switch the background color and label color. If I like the classic mode, I can go back to that. Of course, this is the new default. Maybe I'm preparing a report or a presentation, And so I need to pull some results and take screenshots so I can really quickly switch to a white background. So all of that is here. I can also save themes and load them back in later. So if I want to customize certain things, I can do that. And they have a label color option up here as well. So maybe I like this default background, but maybe it's hard for me to see this red color up here. I can come into label color, I can say black, and then I can use this. So that was really quick. Maybe I want them to be white. It's not going to work as well on this background. So it's easy to use. Again, I could save this, load it back in for later. I also mentioned best possible graphics. So that lives at File Preferences. And if we come to the Graphics tab, we'll see this best possible graphics is checked now. And because this is checked, some of these other graphic options are going to be grayed out because I'm letting Femap determine what is the best graphics for my current setup. Of course, I could come in, I could uncheck this, and I could start editing it. But most of the time, we're going to be fine to just leave that checked and not worry about it. Let's take a look at our interactive screen entities. So again, this is one of my favorite parts of Femap 12. For any of these entities, it's going to be hard to do it on accident. So for example, if I just hover, it's not going to start. But once my mouse is over it, if I click once, it's going to put a little box around the screen entity. And then when that's there, I can just start to drag it all around the screen. In the case of text like this, so if I have titles or something, right now it's left justified. I can bring it into the middle. Now it's center. Oops. And then if I bring it over here, it'll be right justified. And then for all of these as well, we'll see that there is going to be a little down arrow in the bottom right-hand corner. And if I click that, it's going to open up our view options. So this is the F6 menu, and it's going to open directly to my post title screen. So if I'm wondering where I can control this, I no longer have to hit F6 and then dig around through my view options. I can just hit that arrow and it'll bring me directly to the correct screen if I want to start changing the position here or the titles, things like that. If we look at the legend now, when I click on this, again, it's not just hovering, you have to click, and then if I click and hold, then I can start to drag, and it'll intelligently change based on where I'm dragging it to. And there's some other options here as well. So I can pretty easily switch between the level mode, which is smooth right now, but I can change it onto banded if I like that. Sometimes I like that for reports more. There are also some up and down arrows, and if I start clicking these, we're just on the fly going to start adding and taking away the number of levels that are in our model. So this is pretty cool. Another thing that we can do is just on the fly, if I click on either the min or the max here, it's going to open up this new min max, and then I can specify the contour limits. So maybe I want to go from 0 to 10,000. I can do that just on the fly, and it will update over here. There's some really powerful, and it makes things easier. And again, there's going to be an arrow over here that I can launch into my F6 for the contour legend and levels. So all that's going to be right there. And then I also really like what they've done with our view axis. So if I click on this once, it turns into this cube, which just like everything else, I can start to drag around the model. Cube has a few buttons going on, so let's talk about those. This home button is auto scale. So that's just like if you do Control A, it will center your model and auto scale it out. And then with the cube, you can click on a face and it will snap to that face. You can use these arrows to rotate it around. And then you can also, in addition to clicking on the face, you can click on edges and it'll snap to an edge, and even corners. So this makes it really easy to snap around. You don't have to use the view toolbar that we used to have. You can just snap here, quickly auto scale. So I really love what they've done with that. And then if I just click away from it, then it'll go back to my normal view axis. The last thing I want to point out in terms of visualization are the new feature lines. So this is going to live in the F6 menu. And then if I go to Tools and View Style, I have this new feature line. So let's open that up, and I'm going to draw this now. So what this does is it's mesh-based, and it's going to draw a line everywhere that it exceeds an angle tolerance. So by default, the angle tolerance is 5 degrees. Maybe for a tetrahedral element, we probably don't want it to point out all of our tetrahedral boundaries. So maybe if I increase this to 30 or something like that, we'll still get boundaries on our sharp corners, but then it's not going to be along the middle here. We can also break based on property or material if we want to do that. And in addition, we can change the color. So maybe if I'm displaying results, especially if I have this magenta color up, that it makes the red a little hard to see. So I can come in and I can make it black now. And so this is, at least in my opinion, another great visualization enhancement. The other thing that I want to point out here is the difference between the default feature lines and our silhouette line. So right now it's on just regular feature lines. If I switch to silhouette, what we'll see is that now we have lines along our cylindrical faces or our spherical faces where they pass out of view. So I like having this along my cylinders as well. There's two other options as well. So right now I have it set to all elements, which means if I come up and start hiding elements, maybe I'm going to use my draw erase toolbar and I'll just quickly hide the end of that. I still have my feature lines shown down here, which in some cases is what we want. I think that's pretty cool. But at other times, maybe we don't want that to happen. So I can come down and I can switch to drawn elements. And then it will only do the elements that are currently displayed. There's a question in the chat from Jeff. Is it possible to set the levels to round numbers, such as the min and max? I don't think there are right now. I sort of did it just manually by setting from 0 to 10,000 and then changing the levels here. I can look into that more though. I do believe that the feature lines should move when the part deflects. In fact, this part is deflected a little bit right now. Let me try to increase that. Let's just make the scale really big. So yep, so those feature lines do move with deformed geometry now. So good questions, thanks guys. We're going to hop back over to Femap now, or back to PowerPoint, excuse me, and take a look at some of the geometry changes. The first thing that I'll point out for geometry is that the stitching algorithm has been completely redone. Previously, it would make copies of surfaces and it would stitch those copies together. But with the new stitching algorithm, it's going to maintain our surfaces. So what this means is if we have surface-based loads, surface-based boundary conditions, contact definitions, things like that, when we're stitching geometry together, it will remember all of those entities and that will be in our new stitched part. So it's very powerful. In addition, it's controlled by a tolerance, so you can control how close geometry needs to be in order for it to be stitched together. And handling of combined curves and surfaces is included in this. So all of this will extend to our Boolean operations, such as Boolean add or things like that. Next up is surface alignment. And this is what this picture in the bottom left-hand corner is going to be showing. Sometimes, especially with periodic surfaces, we might read in the geometry and it will try to split these surfaces, but sometimes we either get two splits or the splits are slightly off between neighboring surfaces. And so what would happen if I tried to mesh this part now, I'm going to have really small elements in this on the small edge right here. So they've introduced a new surface alignment command. And what this does is it goes in and it just makes all of these curves in the same place. Now you can specify specific curves to do, or you can do your whole model at once. So we'll take a look at that in a second. And then finally, they've introduced some new surface between curves commands. Previously, we only had ruled, which sometimes is what you want, but sometimes we need more options. So they have introduced a tangent option. This is tangent to surface. And they've also introduced a vector option. So this is tangent to vector. And we'll take a look at this as well. So let's hop back over to Femap now. So first, for surface alignment, this is just a quick part that I made up with some cylinders. And we see right off the bat that, we have a small edge here. This probably isn't going to mesh great unless I have a really small mesh size. Again, I can snap to the front. It's clearly not aligned. So we can take care of this really easily with that new command. Again, that was that modify, update other, align surface parameters. I'm going to choose all surfaces on a solid, so it'll ask me to pick a solid. And then to start, let's just see what it does with automatic. So we'll say, okay, I'll pick my solid. It's going to grab all the surfaces on this now. And just like that, it aligns them all. So they're all lined up really nice. But, maybe we wanted to keep it along this XZ plane. So I can go and I can launch that command again. And this time I'll say along vector. So I'll pick my part. And then I'm going to change to global axis. And I just want the X direction. I'll just leave it like it is. And when I say OK, Just like that, now all of our periodic surfaces are split along that plane. You can also take advantage of the new snapping options with this cube. And so maybe I want to actually have it on a 45-degree angle or something like that. I can actually come over and I can align that to my screen. And then if I do this same command again, align surface parameters, this time, oh, I'm going to select the solid. This time for the vector, I'm just going to say normal to view because I just snapped my view to this corner now. And so when I say OK, now we're going to have things lined up there. So there's some pretty cool options here. I really like being able to take advantage of this in my models. The other thing I wanted to show off was some of the new surface between curve commands. So this model just has the same simple geometry copied 4 times so we can see what our different options are. We'll say geometry, surface, ruled / between curves. And then it's going to ask, for start, let's just see what the original was. So we could just do ruled on both sides. So we'll say curve 1, curve 2, and OK. So it just creates a ruled surface, sort of like we would expect. We have additional options now. So I can say tangent to surface. And when I select my curve, it knows what surface that curve is a part of. So by default, it's going to assume that I want surface 3. And in this case, for this first curve, I do want surface 3. And it knows I want surface 4 over here now, because that's what curve 12 is on. So if I say OK, now we'll see that that's tangent to both surfaces. We can also take a look at along vector. So now again, I'm going to do along vector on both sides. We'll say curve 1, curve 2. This time when I say OK, it's going to ask me what my vector that I want to align is. So first it's asking me my from vector, so that's going to be on the left. So I'll say tangent to this curve. We see that the curve is pointed in the wrong direction, so I'll just say reverse direction, and I can preview that. So we're OK there, and then I can say tangent over here now. That's in the right direction already. So we'll say OK, and then now we're tangent to both of those. And then finally, we can mix and match. So maybe I want to do a long vector on the right, but maybe I want it to be tangent to the surface on the left. So I can choose that curve again. Again, it guesses the correct surface. And then when I say OK, it's going to ask for my from vector again. So that's great. Sort of what we would expect, but it's just great that they're giving us additional options. And you can start getting into the parameters even more if you want to dig into that a little bit. Let's hop back over to the PowerPoint now and keep moving. So the meshing toolbox got some attention as well. And these first 2 items are going to be speed improvements. So first, we have feature removal is now 30 times faster, which is really cool. So if we're removing holes, maybe we have a lot of holes in our model and we're trying to eliminate hundreds of holes at once or something like that. This will do it very quickly, which is pretty exciting. And they've also made an 8 times speed improvement to interactive remeshing. So this is in the meshing toolbox. Maybe I've meshed a part, and then I'm going in and I'm interactively changing the mesh size on edges and refining my mesh, doing something like that. You can have interactive remeshing on, but if your model is very big, sometimes it starts to bog down because now it's trying to remesh everything at once. Well, they went through and they redid that. So now it's 8 times faster. So you can get away with interactive remeshing on even larger models than you could before. The other thing that I'll point out on the screen are washers and pads. So washers and pads are now available through solid parts. That's what I've shown here on the bottom right. The washer and pad through a hex mesh, and I'll do a demo of this as well. It would also work if it was a tetrahedral mesh. In addition, washers are now available around non-circular holes. So on the bottom right now, this is nice smooth tangent curves that we see. It just puts a nice offset around. It also works if you have more jagged edges. So maybe we have sharp corners now. What the software will do is, depending on the angle of the corner, in some cases it will put an element around those corners, but in other cases, if the angle is too narrow, it will just sort of cut off that corner. So it can handle non-tangent cutouts as well. The other thing that I want to point out before we get back to Femap is for this feature removal tool and the interactive remeshing and even the washers and pads, everything that we're going to talk about today have all been user requests for the most part, where users tell the Femap developers, this is what we would love to see. This is what would really help us out. And they love to get that feedback. So you can give that to them, you can give that to us, and we'll pass it along. Using this feature removal, for example, I've heard the developers tell the story that they had a user contact them and say, feature removal just seemed slow before. So the Femap developers took a look, and in just a single day, they were able to rewrite the code and get this 30 times speed improvement. So they love having feedback, and things like this were really easy for them to implement. So let's see how some of that works now. I'm going to open up Femap 11.4.2 now. So I'm taking a step back from Femap 12 just to see that feature removal and how much faster it is. This is just a simple plate. This is a solid part with 100 holes in it. And in Femap 11.4.2, I'm just going to try and remove the bottom two rows now. So I'm going to remove loops, and I just turned on my select button. So I can just hold shift, draw a box, and I can remove those. Now it's taken a couple seconds. It's not terrible, but if I had a really big model, you can imagine that it would be a pain if I was trying to do that throughout the whole model. Now if we go into Femap 12, I have the exact same part. So again, we have a solid part with 100 holes. I'm going to open up the meshing toolbox, feature removal, and I'm going to remove all of these super fast. So you can see that's way faster for five times the number of holes. So it's really powerful. I can even do that again just because it's so quick. So things like this are really cool to show off. Like, it's pretty exciting when they can make a 30 times speed improvement on something. We can also look at our washers and pads through solid parts. So this is just a block that I made, and I kind of drilled 2 holes and put this plus shape in the middle. I don't have a mesh or anything on it now. So to start, let's just put a hex mesh on it. I'll come up into mesh control, size on solid. So what this is going to do is I'm just telling Femap, hey, I want to do a hex mesh here. I'll say 0.33 for our element size. So the part turns blue, letting me know that it can hex mesh this. All these little spots that showed up are my mesh size. So that lets us know how many nodes it's going to try and put along each curve. And then what I can do is I can come back and I can just say mesh, geometry, hex mesh solids. I'm just going to use the meshing attributes that are already on there. And so since I just had the one solid, I went ahead and selected it. I'm going to turn the nodes off. So we get a pretty good hex mesh through here. In some cases, though, we might want to have a nice mapped mesh, like a pad or a washer around our holes. And now we can do that through solid parts. So I'm going to come over to geometry editing. And then if I go to pad, now we'll see that I have this new split solid command, or new checkbox. So I'll check that on. I'll come up and select now, and I can just select a curve. And on the fly, we see that it put in a new pad. Down in our message window, we'll see that it remeshed everything. And this goes all the way through the solid now. So it's on both sides of our solid. And in fact, if I hide the elements, we'll see that it actually made changes to the underlying geometry. So it did go through and split. It extruded that pad all the way through. I could come up to the dry erase toolbar. I could hide this. So it's totally new pieces of geometry. But it remembered that these are all stitched together. So all of our nodes are already included. It knows that it wants to be hex meshed. It's very powerful. I can also come over and I can do washers now. So I already have split solid selected. So we'll do the same thing here. Now I have a nice washer. And just like before, you can control the size of the washer. Right now I have it on factor. So it's just a factor of the radius or the diameter. But I could also set a distance if I knew a specific distance that I knew I wanted my washer pad to be. And then the other thing to show off here is non-circular loops. So I'll come and I'll check this, include non-circular loops, excuse me. And then I click this. It's going to create all those surfaces. It's going to remesh everything. And then we see we have all these new surfaces with a nice washer around that. If I hide this again, this is all new meshes that it stitched together. It knows they're supposed to be connected. And we get a nice hex mesh through there. This would work as well if this was a tetrahedral mesh. It would do the same thing. So some cool stuff going on with the meshing toolbox. Back over to PowerPoint now. I also like to talk about the new copy commands. So there's some powerful stuff happening here as well. Previously, if you had geometry and you had a mesh on that geometry and there were loads and things, and you needed to copy that, you could copy the geometry or you could copy the mesh, but you couldn't copy them together. And you could copy them both separately, but then they wouldn't be associated to each other anymore. which is sort of a pain. So what they've done is they've gone in and for the copy, rotate, and reflect commands, now you can copy geometry with the associated mesh and vice versa. And it's not just the mesh, it's also loads that are defined, boundary conditions. If you have contact regions or connections set up already, you can now copy all of this together all at once with just a single click, a single operation. In addition, inside our copy operations, they've added some new numbering options. So now you can do block renumbering if you want to renumber everything to a certain range. And you can also offset numbers. So maybe you want each copy to be incremented by 1,000 numbers off. In addition, this applies to move commands too. So maybe I don't want to copy my geometry, maybe I just need to move it in space. Previously, you couldn't do the mesh and the geometry at the same time and keep it associated, but that's a new move option as well. So I'll demo some of these copy commands in a minute. The two images at the bottom of the screen right now are showing a pretty cool example. So this is a sheet part, and it has a surface mesh on the geometry. You can also see that the surface mesh has a pretty complex nodal temperature distribution right now. So it would be a pain if I had to start copying this as I copied it around. In addition, there are coordinate systems that are defined on the geometry that are not the global coordinate system. And then there's also constraints that are based on those coordinate systems. So then on the right, we see that they made a bunch of copies of this. And for each copy, just all at once, it copied the geometry, the mesh, the loads, the boundary conditions, all our new coordinate systems. So it knew what all it needed to include, and it copied all of those every time. They made some similar enhancements to file merge. In format file merge, it seems like some people either haven't used it before or didn't know it's here. So I'll sort of explain everything this is while also highlighting the new option. So file merge is at file merge, as you would expect. And what this did previously was if you had two separate Femap models open, you could use file merge to copy part or an entire model into another second model. What they've done now is they've added this new option at the top to copy in the current model. So you can actually just copy something directly within the same model that you started off in. So that's pretty cool. Inside the model merge manager, it's going to let you choose if you want to copy points, curves, gives you options for what you want to merge and how you want to renumber those. You have options if you want to do the entire model or just a group. But the other new thing that they've added into file merge is orientation and transforming things. So now, if we're copying either between models or within a model, we can now choose if we want that copy to be offset a certain location. So the ability to do this sort of came hand in hand with the ability to copy our geometry and mesh together. So these sort of go together pretty nicely. The other thing I want to show off before we go back to Femap, or the other thing I want to introduce, excuse me, is the Beam Centerline Finder. So this is actually an API command that you might have heard us mention for Femap 11.4, but now it's not just an API command anymore. It's a full command in Femap. This is really exciting. What it does is it will look at your solid geometry. Maybe you have piping or other items that you want to create a 1D mesh for, and you have just the solid geometry for it. For that geometry, it will find the center line down the center of that geometry, and it will also identify a cross section. And so it will create curves down the center line, and it will apply properties to those curves that have the correct cross sections, the correct offsets and everything, so that then you can very quickly go in and create your 1D mesh. Circular cross sections will be given the same property. It has a little bit of a trickier time with non-circular cross sections, so it defines those as just general cross sections, and so each of those would end up as a separate property. So let's take a look at this in action. So I'm going to hop back over to Femap 12 now. And what I have here is just a quick, simple truss structure that I made up. This is all geometry, so if I come in and I hide the geometry, there's going to be nothing left. So like there's no curves underneath this or anything. If I want to do a 1D mesh before, I would need to come through and I would need to define curves along all these different solid parts. I would need to create my cross section, and then I could mesh it. But with Femap 12, I can do all of that at once. So let's take a look at that in action. I'm going to come to Geometry, Curve, Centerline. Now I have a material in this model already. I should point out that I don't have any properties or anything now. I do have a material already, so I can use this material. If I didn't, I could create a material, or I could use the material if I already had a material specified in this geometry. So we'll say OK, and then I'm going to pick my solids that I want it to work on. And then that was it running. So it ran really fast. I'm going to come in now and I'm going to hide my solid geometry since we're done with that now. We have these new curves that were created along the center line. And if I turn on our cross section, we'll see that each of these curves actually have the right cross section already. So if I turn it on, the cross section is going to line up. So if I want to mesh this, it's as easy as just saying mesh geometry curve. I can select all of these curves. And I'm going to use the meshing attributes. I'm going to use the properties that are already defined for those curves because they have the cross section and the material already. We'll say OK. And it's going to create all of our nodes and elements. This is pretty cool. I like this a lot. But we can kind of use this to look at our copy commands too. So first, let's maybe put a load on the tip here, and then we'll put some constraints back here. I'll just do that with model load. Let's do it on the points. So we're adding loads to our geometry now. So it's just going to be a plus y load. I'll just say 10. And then I can add a constraint to the backside now. Maybe let's do the constraints on nodes instead. And then I can say fix. I can just fix all those. So we have our constraints on the back. And then maybe this is actually like a truss structure, like a bridge or something. So I want to create a copy of this. I can mirror it. In this case, I'm just going to copy it with geometry, copy curve. So I'm copying the curves, and that's what it's asking me to select right now. But once I get to this copy options page, we'll see that I have some other options for including additional entities. So it asks if I want to copy the mesh. In this case, I do. And I'm OK using the same properties. It also asks if I want to copy the loads and the constraints. So that's great. We want all that. Maybe I want to offset everything by 100 for this copy. So I'll say OK. Then I'll enter my new vector. I'm just going to use the global axis. And we'll just say the negative z direction. And maybe I'll just move it over 40. We'll say, OK, we got a copy of the curves. If I turn the elements off, we have new curves. We have our elements. We have our loads, which were defined on the geometry, and our constraints, which were applied on the nodes. So it copied all of that, which is pretty exciting. Maybe I realized that 40 is wider than I wanted. Maybe I only wanted it 30 over. I can come back in, and this time I can do modify move by. And I can say curves. And again, I'm moving the curves, but it will ask if I want to move the mesh with it, which is awesome. We'll say OK. This time I want to go 10 back in the Z. So just like that, we can copy all that around. And then maybe I want to add some horizontal truss structures back. So let's say geometry. I'm just going to create a line between 2 points. And then I'm just going to mesh this really quick. And I'll use the same property that was already created by the beam centerline command. Define an orientation. So we have our new beam elements across here. I can copy all of these really quick, and I'll show you how I'm going to do that. I'm going to say, in this case, before I was copying the geometry, now maybe let's copy the mesh. So I'll say mesh, copy, element, and then I'll pick these 3 elements. It knows that they're on the same curve, so it's just going to copy a single curve along with each one. But in this case, I'm going to check off loads, because I don't really want to copy this load all throughout my model. In this case, I'm going to do move to, and I'm going to use this auto repeat copy. So what this does is I won't have to reselect the elements that I want to copy every single time. So that'll speed us up a lot. That's going to ask where I want to copy from. So I'm copying from right here. And then it's going to ask where I want to copy to. So I want to copy to here. But then it's just going to keep launching this copy to command. So I want to copy to there as well. And just all throughout my model, I can come really quickly now and just start copying those horizontal elements. So if I hide my elements, we have the curves along as well. So this is really cool and moves really quick. One thing to point out is that none of these nodes are merged. So I can come back in now and I can say check coincident nodes. And if I just select them all, and I'll just use the defaults. So it did find 18 nodes to merge. So just keep that in mind as you're doing this and copying things around, that you still need to be careful for coincident nodes to make sure that your model is still attached. Head back over to PowerPoint now. There's a couple other things I want to point out for pre-processing. The first is a mesh point editor. So this is going to be a new pane, just like the meshing toolbox or the data table. And mesh point editor lets you create hard mesh points. So this is telling Femap that you absolutely want a node at a specific location, and you can specify that location using coordinates, points, or nodes that are already in your model, or from file. So if you have an Excel list of mesh points that you need, maybe you know where all of your fasteners are or something like that, you can copy all those to the model really quickly. You can also copy your mesh points from the mesh point editor out of the model back to Excel or something. So really quick, a lot of options to create those. Each time you create a mesh point, you can also have it automatically connect to nearby geometry and snap to nearby geometry. And then what we'll see in the mesh point editor is for each one, we'll see if it's currently associated to any geometry. We could have it associated to a surface or to a curve or to a point. It will tell us the distance to that geometry. So in this case, all these points are on the surface, so the distance is 0. And then it gives us the point of the mesh point as well as the point on the geometry. Again, for the example in this image, it's all on the geometry. So the geometry point and the point are going to be the same. One last note here is that mesh edits observe mesh points. So I'll show what I mean by this in a second. But basically, if you're interactively remeshing, the mesh points are permanent as long as you don't delete them. So if you remesh, the mesh points will still be there. You don't have to reapply them every single time. There's a few other pre-processing enhancements to point at. The first is going to be data mapping enhancements. First, they've increased the speed for some of the data mapping algorithms, which is pretty great. In addition, you can now do criteria-based mapping onto elements, which is very handy. And then the other thing they've done is when you're doing your data mapping, maybe from one model to another, previously you would need a group in your original model so you could specify what elements you were trying to copy data from. Now there's an all-compatible element, so you don't have to have that source group. They've also introduced cohesive elements, and I'm not going to get too far into this. Cohesive elements are, or can be used in the new NX Nastran Solutions 400 and 401. And one caveat for cohesive elements is that the thickness of the cohesive element is calculated using the property thickness. So the element itself, it's a brick element, sort of like a hex element. The physical thickness of that element isn't important. The thickness is based on the property card. So the element itself could have 0 physical thickness and have coincident nodes. Again, the thickness is based on the property. And there's a new mesh editing cohesive meshing command that can insert these elements, similar to the edge split command that we had before. Previously, or in addition, there are new discrete value plots. So this lets you plot all of your entities either based on selected material or property values, such as Young's modulus or a property thickness, or on entity ID. So these two examples over here, this top image the elements are colored based on property ID, and you can see over here that the legend is specifying, the red color is property 1. In the bottom, it's plotting element ID. So it's giving ranges. For example, these green elements are elements 85 through 112. So let's take a look at some of that in Femap as well now. I have this surface. It has there's a message in the chat that the Zoom cuts some things off, so I'll try to work a little bit higher in the screen to avoid that happening. So I have this next example model. We have 4 surfaces. They each have a different property assigned with a different thickness defined. So really quickly, I can fill in all these holes and create mesh points using the meshing toolbox. So I'll just say add surface mesh point. And then now when I do this, we're going to get points right away. And then I can, staying in the meshing toolbox, I can mesh all these now. So I'll just say mesh sizing or mesh surface I want to do a mapped mesh, and I want my mesh size to be 1. So I can come through now, and I can mesh all that. But we'll see that the mesh size is not a great fit if I want to have a node, or if I want to have a node right in the middle. It doesn't really line up with the mesh size. So I can go back to mesh sizing, and it's going to remember that I have a mesh point here, and I can go through and I can start increasing. Now, because it's a mapped mesh, it knows that I want to increase the other side, and I can actually do all 4 at once, just interactively. So it remembers where I want my mesh points to be, and I can open my mesh point editor too and see those mesh points that were defined. So this is just like meshing Toolbox or anything. You can have it docked. You can also pull it out and have it on its own. So it's going to show my 4 points. They're on the surface. So the distance to the geometry is 0. I could copy these if I wanted to copy them to clipboard, if I wanted to load in new mesh points from a file or something. There's some cool options here. I'm just going to dock that back for now. And I want to show some discrete value plots as well, just very briefly. So those are under View, Advanced Post, Contour Model Data. Maybe first we want to look just at property ID. So let's turn on our discrete value plots, and we'll just say OK. So then each of these property areas are a different color, and that corresponds to the legend. So the legend is telling us that this is property 1, 2, 3, and 4. You can also do ranges over there. So maybe I want to pull up that command again. Maybe I want to look at element thickness now. So this is based on the property. And I can create a new discrete value plot. Maybe instead of individual value, maybe I want a range. And maybe I only want 3 ranges. We'll say OK. Now the legend has changed to be a range. And for example, we'll see that this brown color is 0.05 to 0.1. So that's going to be that these 2 sections, the first and third section, are 0.05 to 0.1. So in this small model, it's not helping us out visually a ton, but if you had a really big model, you can imagine how this might begin to be very useful. So we're running towards the end of our time, so I'm just going to kind of get through these last ones sort of quick. On the post-processing side of things, they've added a really cool interactive adjust limits for dynamic criteria. So now if you're looking at a criteria plot, you can actually open up this little window and you can grab the status bar and start dragging it back and forth. We'll take a look at that in the model. And another cool thing here is that you can create a group based on a criteria plot. So maybe you've done a topology optimization run and you're plotting normalized mass density, for example. You can set up the criteria limits to show you everything above maybe 50%, and then you can create a group based on that. They also have options, and I don't have it on the slide, but they have options where you could export a criteria plot like that as solid geometry. So that's pretty cool as well. They've also added a new visible min-max, and so this is a level mode for our contour bar. Previously, there were a few other options in there, but if you started hiding elements, your legend might not change. With this new visible min-max mode, it will. A few other post-processing notes. There is now a previous on button for our select output and select output sets. So we've had options like this previously if we were selecting nodes or elements, where if you had another dialog box, you could click previous to get the same selection that you had for the last similar command. Now we see that for post-processing too. So maybe you output some data to the data table and you had selected a variety of different vectors. The next time you came in to a similar dialog box, you could push this button and it would just recheck all those because it would remember. There's also a new option to transform results as you're sending them to the data table. So maybe you want to transform results to a different coordinate system or something. You can do that on the fly now. And then finally, there's a report generator. So this is going to work with Microsoft Word. And the user can select entities. You can select the results that you want to display, and it will summarize all of these in a user-defined layout and with user-defined views in a Microsoft Word document. So that would look something like this now, where it's going to start grabbing screenshots. Let's go back to Femap, look at this briefly. First, I'm just going to go back to my first model now. And I'm going to change to, or from contour to criteria. And then if I open up our dynamic control, I can uncheck the labels here. And then I can switch to between. And so now I'm going to have slide bars that just let me really quick on the fly start to adjust which elements are displayed, what matches the criteria and what doesn't. And then again, based on this, I could come in and I could say, not custom tools, I could say group operations generate from criteria. And that would create a group of just the elements that meet the current criteria. I can also show off the report tool really quick. So that's under Tools, Report Generator. It's going to ask if I want to start filling in my name and my company. On the entity page, you can choose which load sets and constraints and output and things you want. And then if I just say create report, so it's writing my report. It's going to be really fast. So it just finished. And I have this new Word file that opened up. And if I start coming through here, we'll see geometry information, our material data. We have plots of our load set. The loads are applied to the end over here, and that's cut off on this model, unfortunately. But we see where our constraints are. We see what our contact definitions were. You get plots of von Mises stress, and I could have multiple plots on this page if I had set that up. So it's not going to get you all the way to your final report, but it might help you out in some cases. So back to PowerPoint now. Let's wrap things up with some solver updates. So for NX Nastran, they have added support for solutions 400 and 401, which are multi-step, nonlinear structural and kinematic solutions. I'm not going to get too in-depth here because this warrants more time than we have remaining. But I invite you to visit our site where we have more information. You can also contact me if you want. I have some tutorial videos and things that I could share with you. These new nonlinear options are very powerful. So you can have multiple subcases. The subcases can be dependent or independent. You can change analysis type between subcases. So maybe you want to start with a preload and then you want to run modes on that. You can do that with consecutive subcases. You can change contact between subcases. So there's a lot of options there. And then we've also added support for solution 200 optimization, both design optimization and topology optimization. So again, all of this is through NX Nastran 12. So it's been out for a little bit already, but then now Femap 12 is adding support for that. And it's adding support through additional options in the analysis manager. So you have additional dialog windows and dialog boxes just to set up some more of the properties that you need for these specific analysis types. In addition, NX Nastran 12 brings some new memory management. So now we have both a fixed allocation, which would be our database functions, as well as dynamic allocation. So what we would see is if we specify a value on using the memory keyword, this is now a high watermark. So it's not necessarily going to be using all of that memory all the time. We also see some improvements for ANSYS and Abacus solver. And ANSYS is probably the most impressive here. The ANSYS translator has been 100% completely rebuilt from the ground up. So they completely scratched the old one and started fresh. This new ANSYS translator should have seamless data transfer between Femap and ANSYS, and it actually works as a compiler. So Femap will let you know whether you're writing a model, an ANSYS model out, or reading one in. It will let you know what those errors are. It won't just leave you to try and guess and figure that out on your own. This new translator for ANSYS it supports modern ANSYS element types, and it supports a more organized ANSYS input file creation, and you'll have more opportunity to define keywords and things that are applicable for ANSYS. And probably the best part of all this is that with this enhanced code architecture, we have easier future additions. So as ANSYS moves forward, if they continue to add new element types and new material models, it'll be really easy for the Femap developers to add support for that as well. Abacus saw a little addition as well in the form of expanded support for rigid analytic surfaces, as well as support of CBush as Con 3D2 elements. There was also a question in the chat if there were any LS-DYNA updates. I am not aware of any, but I will check on that and I'll let you know if I find any. So we kind of flew through a lot of stuff. So just to quickly recap everything we talked about. We started off with user interface. We saw kind of a refreshed view colors, some active screen entities where you can start dragging legends and titles around the screen and edit them on the fly. We see new feature and silhouette lines. Then for the geometry and meshing toolbox, We saw the new stitching algorithm, the feature removal tool saw 30 times speed improvement, and pads and washers are now available through solid geometry and around non-circular holes. For pre-processing, we saw some pretty cool enhancements to our copy commands, so we can now copy geometry and mesh together at the same time and keep them associated. We also demoed the beam Centerline finder, which is no longer just an API, it's now a regular command in Femap. And we took a look at the mesh point editor. For post-processing, we saw the dynamic criteria options that are interactive now. We also saw visible min-max contour level mode, the ability to transform results while we're sending them to the data table and the report generator. And then finally, for solver support. For NX Nastran, we saw the addition of, we saw additional support for solutions 401, 402 nonlinear, as well as solution 200 optimization. And then for ANSYS, we have an entirely new translator. So that wraps up the presentation for today. I'm going to let you guys unmute yourselves now if you have any other questions. And I know there were a couple questions that I missed in the chat, so I'll go in the meantime and try to answer some of those as well. So feel free to unmute yourself if you have any questions. So Bryce asked the question back on the non-circular loops. I would need to look back to figure out how the factor is calculated. I'm not sure if it's looking, let me go back to that slide. So it's more a question on places like this, how does it determine that factor? Normally it would just be when you put factor in, it would be just like a factor of the radius. I would need to go back and play more. That's a good question. If it's a factor of the smallest radius, Bryce, I'll look into that and I'll let you know. Were there any other questions, either through the chat or if you want to unmute yourself for questions?
I have a question about the cohesive elements. Is the inspiration to model coatings like electroless nickel, optical coatings, paint? What's the idea for using that, the concept, the use case?
Sure. My understanding is that it's more for damage, like if you wanted to have elements like for a composite material or something. I can look into that a little more as well and send you the info that I have on cohesive elements. Great. Well, thank you everyone for attending today. If you have any questions, definitely reach out to me, reach out to our software sales team. We're here to help for you. So just let us know how we can help. And be on the lookout. We'll have this video posted on our website probably later this week, so you can review it or share with colleagues or anything. Great. Thanks, everyone.